We live in a vast universe, filled with mysteries that can reshape our understanding of ourselves and the world around us. Since the early days when humanity looked up at the starry skies, we have asked, what's out there? And wondered how much we really know about this universe. Some theories, if proven true, could change everything we have ever believed to be true. Let's explore the top 10 space theories that hold the potential to change everything. Parallel universe theory. Have you ever wondered if there might be another world, parallel to ours, where you're living a completely different life? In the 1950s, physicist Hugh Everett proposed the idea of parallel universes, suggesting that every decision you make creates a new branch, in reality a separate world where things happen differently. Imagine you're standing at a crossroads and choose the left path. In a parallel universe, you might have taken the right path, leading to a completely different life. The principle of the butterfly effect in chaos theory also describes how a small change, like the flap of a butterfly's wings, can lead to massive consequences. If this theory is true, then every event in our lives could create countless different versions of ourselves in parallel universes. We might be existing simultaneously in multiple worlds, each one with a different outcome. However, science has yet to find a way to prove the existence of these parallel universes. Quantum black hole theory. Black holes are among the most mysterious phenomena in the universe. But Stephen Hawking once proposed the idea of quantum black holes, tiny black holes the size of an atom. These black holes, although minuscule, could contain some of the biggest secrets of the universe. In 1971, Hawking suggested that quantum black holes might be scattered throughout the universe in places invisible to the naked eye. Some scientists believe that these micro black holes might serve as gateways to other dimensions. If one day we can harness quantum black holes, it could open up possibilities for traveling through the universe that were once only possible in science fiction. However, proving their existence would require technology far beyond what we have today. 3. String theory. String theory is one of the most complex theories in modern physics. According to this theory, every fundamental particle in the universe isn't just a point, but a tiny string vibrating in space, with a size only a trillionth of an atom. This theory was developed by physicist Leonard Susskind in the 1970s to unify all the natural forces within a single framework. Imagine each particle as a musical note in the universe's symphony, and each natural force as a melody within this grand composition. If string theory is true, it would give us a completely new perspective on the universe. However, the greatest challenge of string theory lies in observing and testing these tiny strings. With current technology, we are still unable to detect the minute dimensions that this theory describes. 4. Bubble universe theory. This theory suggests that our universe is merely a bubble floating in a vast cosmic sea, surrounded by billions of other bubbles. Each bubble could be a separate universe with its own unique physical laws. Imagine that each universe is like a bubble in a pond, each one isolated and distinct. Sometimes these bubbles might collide or even connect with one another. Some scientists believe that the phenomenon known as the cold spot in cosmic microwave background radiation may be a remnant of a collision between our universe and another bubble universe. If the bubble universe theory is correct, then the existence of millions of other universes is entirely possible. Some of these universes might even have life, technologies, and laws that are completely alien to us. 5. Dark matter theory. Dark matter is one of the biggest mysteries in modern astronomy. Although we can't see or feel it, dark matter accounts for about 27% of the universe's total mass energy content. In 1933, astronomer Fritz Zwicky observed that the stars in a galaxy cluster were moving much faster than expected, which suggested that a hidden amount of matter, something we couldn't see, was present. Dark matter plays a role in holding galaxies together, acting like an invisible gravitational force. Without dark matter, galaxies would not have enough force to keep their stars together, and the universe would have a completely different structure. Understanding dark matter could help us reveal more about the universe's structure, and possibly even discover new energy sources. 6. Dark energy theory. Dark energy is a mysterious form of energy that is causing galaxies to expand away from each other at an accelerating rate. Observations from the Hubble telescope in the 1990s showed that galaxies are drifting farther apart faster and faster. This has led to the hypothesis of dark energy, an invisible force that pushes galaxies away from each other. If we can learn more about dark energy, it could help us predict the universe's future. Will it keep expanding forever, or will it one day collapse back into a single point? 7. Time travel theory. The theory of wormholes suggests that there may be shortcuts in space-time that could allow us to travel to different times in the universe. In 1935, Albert Einstein and Nathan Rosen proposed the idea of wormholes, where space and time could fold to create a shortcut between two distant points. If time travel were to become possible, it would change how we view the past and the future completely. However, it remains a huge challenge, requiring monumental advances in science and technology. 8. The Higgs particle and the origin of mass. The Higgs particle, also known as the God particle, is responsible for giving other particles their mass. In 2012, after decades of research, scientists at CERN discovered the Higgs particle, confirming physicist Peter Higgs's theory. Without the Higgs particle, particles would have no mass and wouldn't be able to form structures like planets or stars. Discovering the Higgs particle helps us understand the nature of matter and opens doors for future technological applications. 9. Antimatter theory. Antimatter is a unique type of matter that, when it collides with regular matter, produces enormous energy. Experiments at CERN successfully produced a small amount of antimatter. When antimatter collides with matter, it releases energy hundreds of times greater than nuclear energy, offering the potential for an abundant energy source in the future. But antimatter also presents enormous risks due to its explosive potential. Finding a safe way to harness antimatter remains a huge question. 10. The Big Bang theory. The Big Bang theory is the most widely accepted theory of the universe's origin, proposing that the universe began as an extremely hot and dense point, and then expanded outward. In 1927, astronomer Georges Lemaitre introduced this theory. Later observations showed galaxies moving away from each other, confirming that the universe is expanding and started from a single origin point. The Big Bang theory helps us understand the birth of the universe and raises questions about its fate, whether it will continue expanding forever or eventually collapse back into a single point. These 10 space theories, each with its own set of mysteries and intriguing possibilities, open up new perspectives on this vast universe. Which of these theories do you think is most likely to become reality? Or do you believe the universe holds even greater mysteries beyond these theories? Let's continue the journey of discovery. Share your thoughts.